So, first of all, we're going to answer question number 1 first. A small electronic box contains a total of 7 components consisting of 4 microchips, 2 resistors, and 1 capacitor. A technician randomly selects a sample of 3 components from the box without replacement for testing purposes. And in this experiment, let X represent the number of microchips selected in the sample, and let Y represent the number of resistors selected. And for question A1, they want us to find the joint probability distributions and marginal distributions of X and Y, and they want us to determine whether X and Y are independent. So, for this question, we have to take out some important information, which we have to know that the number of chips is represented by X, while number of resistors is represented by Y. And then the value of X equals to 4, and the value of Y equals to 2. So, how can we find the joint probability distributions and marginal distributions of X and Y? First of all, we have to construct a table. And in this table, we must have the value of X, Y, Gx, and Hy. Gx is the marginal of X, while Hy is the marginal of Y. So for X, we have to fill up with the number of 0 up until 3. Y only 3 when there is 4. The reason why we just take from 0 to 3 is because the maximum number of selections is just 3. So we just take from 0 up until 3. So here for Y, we take from 0 until 2, and this is the Gx and Hy. So how can we find that? How can we fill up this table? Is by we must find the probability of all the selections, all the possible selections. So let's take example from this. If I take only X equals to 1, Y equals to 1, then we will have 8 over 35, which is here. And how can we get this value here? This value here is by add up all the value here, then it will be equals to this. And also the same thing goes to here also. We will get the value of Hy by adding up all this thing. And then how can we check? Then we can check the value of Gx, and all of this must be equals to 1, and all of this too must be equals to 1. Okay, now we are going to do another one, which they want us to find whether X and Y are independent. So how can we do this? There is a formula, okay? We make sure that the probability of xy is the same as the multiplications of Gx and Hy. So let's say we want Gx equals to 1, which is here, and then H equals to 1 here. Then the value of probability at y equals to 1 is here. So we have to make sure that the value of Gx multiplied with Hy is equals to 8 over 35. So now we have done that, and then we found that the value of Gx multiplied with Hy is 48 over 245, which are proven that they are not independent. So for question A2, we have to determine the expected X and expected Y. So first of all, we have to begin by remember this formula of expected X, which we just have to multiply X together with Gx. So here we can just take an example right off from the table we just studied from the previous question. So for X equal to 0 will be multiplied together with 1 over 35, and X equals to 1 will be multiplied together with 12 over 35, and then we will all total out all of this and equals to this. And the same thing goes for expected Y, which we just have to multiply the value of Y together with the Hy, which is just have to multiply the value of 0, Y is equal to 0 with Hy equals to 0. So this is 2 over 7, 1 times with 4 over 7, 2 times with 1 over 7, then at the end we will get 6 over 7. So this is the final answer for A2. So for the question number B1, they want us to find the marginal distribution of X and Y, and hence find the probability of X equals or more than 2 or Y equals to 2. So for this question, we just have to find the marginal distributions of X and Y first. So how can we find it? We just have to find the value of X equals to 1 and 2. So we just have to total up this answer, then we will get 43 over 100. And when we total up this X equals to all of this answer, we will get 57 over 100, and this is the marginal distribution of X. So, and all of this will be add up and equals to 1. Next, for marginal distributions of Y, it's just the same as the above one, which we just have to add up all the Y equals to 1, which is this. We just have to add up this, then we'll get 39 over 100. We add up this, then we will get 7 over 20. We add up 0.15 plus 0.11, we will get 30 over 50, and all of this will also equals to 1. So next, this is the conditional distributions, which they want us to find the probability of X more than or equals to 2, condition with Y equals to 2. So how we can find it is just we have to find the value of X equals to 2, which is the 0.22 divided by Y equals to 2. This Y equals to 2 must be either below 1 because it's like the condition one. So we got 0.35, so 0.22 divided with 0.35 will be equals up to 0.6286. So this is the answer for B1. So for question last, which is B2, we have to calculate the covariance of X and Y. So just actually for covariance, we have to remember this formula. This is actually very important. So how to find covariance of XY is just we have to find the expected XY and the expected X times with expected Y. So how to find expected X? So it is actually just basically the same. You have to remember all of this, which to find expected X, then we have to multiply X with Gx. So based on the table above that I have write out in B1, we have to multiply the value of X, which is 1 multiplied with 43 over 100 plus with 2 times with 57 over 100, then we will get 157 over 100. Next, for expected y, we have to multiply the value of y with hy. So this is just the same. We just have to times with the value of y, 1 times with 39 over 100 plus 2 over times with 7 over 20 plus 3 times with 30 over 50. Then we will get 187 over 100. And then the last one, we have to find the expected y, as we have to use it for, it is important as we have to use it in our formula to find the covariance. So by this, you just have to combine all this thing, like 1 times with 0.15, and then at the last one you will have this answer, 72 over 25. Next, but this is not the end, because this you just have the x, but that's why you didn't fill up using this formula yet. So how to find the covariance xy? We just have to use up all the information, all the answer that you have got, which is expected xy will equal to 70 over 25 minus with multiplications of ex and ey, which is 157 over 100 times with 187 over 100. Then you will get negative 0.559. So this is the answer for B2.
So now I will explain for question 2. There are two parts, which are A and B. So the first one is find the marginal densities of x and y, and also calculate px plus y is less than or equals to 2. So the first one is to find marginal density function of x. So we use gx and also dy, integrate it as usual, and then we'll get the final answer, 1 over 60, 8x plus 8, and don't forget the limits, 0 is less than x and also less than 4. Next is marginal density function of y. So we use hy and also dx, and then this is the limit. By the way, the limit is given in the question right here. This one also is the limit from here given. So dx, and then we just integrate it as usual, and we get the final answer, 1 over 60, 9 plus 3y, and don't forget the limits, 0 is less than y and less than 3. So next one is finding px plus y is less than or equals to 2. So the first step is to sketch the graph. So in order to sketch, we have to find the dots first to join it together to become a line for x plus y equals to 2. So when x is equals to 2, y is equals to 0, right here x is equals to 2, y is equals to 0. And when y is equals to 2, x is equals to 0 is right here. So we just join the two dots and we get the straight line for x plus y is equals to 2. So as the question says it is less than or equals to 2, so less than, we'll just shade it under the graph, under the line. So it becomes this one for the final sketch of graph. And then to find dx dy or dy dx, we just move the x here to use dy dx, and move the y here to use dx dy. In this case, I'll use dx dy. So these are the limits, 0, 2, 0, 2 for dy, and also 0, 2, 0, 2 for dy, sorry, and 0, 2 minus y. Here, we got it right here. So as it is less than, so this is the upper limit right here, and the lower limit is 0. So we'll just integrate it as usual, but we have to do double integrate as we have dx and dy and two limits. And then the final answer will be 1 over 15. Next is part B. So let x and y have the joint probability of density function. This is the function and also the limit. So we have to find ex, ey, and exy. We also have to calculate the covariance of x and y, and also are x and y independent. So the first one is to find ex. So in order to find ex, we have to have gx, as the equation is x times with gx, and integrate it. So we have to find gx first. So the limit is 0x as it is given in the question earlier, and use dy. So we have to integrate as usual, and then substitute everything to y, and we'll get the final answer for x cubed. And we'll just put this 4x cubed into this, which is gx. So x times with 4x cubed dx. So we just integrate as usual, and we get the final answer, 4 over 5. Next is to find ey. Same goes to ey. We have to have hy, because the equation is y times with hy, and we have to integrate it. So this is the limit given in the question, and also the original equation. So we just integrate it, and we'll get this 4 times with y minus y cubed. And then we just substitute it here, and then y times with this, and we get this one, and then integrate it as usual, and then we'll get the final answer, 8 over 15. Next is finding exy. So the formula for exy is xy times with fxy. Fxy is the original function given in the question, so we just time it with xy, and we have to double integrate it. So the first limit for dx is 0, 1, and for dy is 0x. So I use dy dx for this question, and then we'll just times it here, so we get this one, and then integrate it as usual, double integration, and we'll get the final answer, 4 over 9. So the last question is to calculate the covariance of x and y. So what is the formula? It is exy minus with ex times with ey. So the exy we got earlier, which is 4 over 9, minus with ex is 4 over 5, and also times with ey, which is 8 over 15. And we got the final answer, 4 over 225. So how to know if it is independent or not? So if it is equals to 0, it means it is independent. If it is not equals to 0, it means it is not independent. So for this case, the covariant x, y is not equals to 0. So since covariant xy is not equals to 0, therefore x and y are not independent. That's all. Thank you.